Welcome to Introduction to AI in Azure, Generative AI. In this course, we'll explore foundational concepts and practical tools for generative AI using Microsoft Azure. Generative AI powers applications that can create content, answer questions, and assist with tasks. In this module, you'll explore the fundamentals of generative AI, including large language models, LLMs, prompts, and AI agents. Let's start by focusing on generative AI and discussing agents and automation. Generative AI, agents, natural language, computer vision, information extraction, and machine learning all play important roles in modern AI solutions. Generative AI and technologies that implement it are increasingly in the public consciousness, even among people who don't work in technology roles or have a background in computer science or machine learning. The futurist and novelist Arthur C. Clarke is quoted as observing that any sufficiently advanced technology is indistinguishable from magic. In the case of generative AI, it does seem to have an almost miraculous ability to produce human-like original content, including poetry, prose, and even computer code. However, there's no wizardry involved in generative AI, just the application of mathematical techniques incrementally discovered and refined over many years of research into statistics, data science, and machine learning. You can gain a high-level understanding of how the magic trick is done by learning the core concepts and principles explored in this module. As you learn more about the generative AI technologies we have today and how it powers a new generation of AI agents, you can help society imagine new possibilities for AI tomorrow. Here's the agenda for our session. First, we'll introduce generative AI concepts, including a lab exercise, followed by a section on getting started with generative AI in Microsoft Foundry, which includes a demo. Now, let's begin our introduction to generative AI concepts. For more learning, you can follow the Microsoft Learn module linked in the presentation. Generative AI is a subset of artificial intelligence where models create original content in response to natural language prompts. It can generate text, images, and code, such as writing cover letters, creating logos, or developing Python code. Applications take in natural language input and return responses in various formats, including natural language, images, and code. Modern language models are built on transformer architectures, using techniques like tokenization and vector embeddings to represent semantic relationships between words. Encoder and decoder blocks use attention layers to process and generate natural language sequences, predicting probable outputs based on input prompts. At the core of generative AI, large language models, LLMs, and their more compact relations, small language models, SLMs, encapsulate the linguistic and semantic relationships between the words and phrases in a vocabulary. The model can use these relationships to reason over natural language input and generate meaningful and relevant responses. Fundamentally, LLMs are trained to generate completions based on prompts. Think of them as being super powerful examples of the predictive text feature on many cell phones. A prompt starts a sequence of text predictions that results in a semantically correct completion. The trick is that the model understands the relationships between words, and it can identify which words in the sequence so far are most likely to influence the next one, and use that to predict the most probable continuation of the sequence. For example, consider the following sentence. I heard a dog bark loudly at a cat. Now, suppose you only heard the first few words. I heard a dog. You know that some of these words are more helpful clues as to what the next word might be than others. You know that heard and dog are strong indicators of what comes next, and that helps you narrow down the probabilities. You know that there's a good chance the sentence will continue as, I heard a dog bark. You're able to guess the next word because you have a large vocabulary of words to draw from. You've learned common linguistic structures, so you know how words relate to one another in meaningful sentences. You have an understanding of semantic concepts associated with words. You know that something you heard must be a sound of some kind, and you know that there are specific sounds that are made by it. The first step in training a transformer model is tokenization, where unique text values are identified as tokens. For example, I heard a dog bark loudly at a cat is broken into tokens, each assigned an ID. This process builds a vocabulary for the model. Step 2 is creating embeddings. Semantic relationships between tokens are encoded as vectors. For example, dog, cat, and puppy have similar vector orientations, while skateboard is different. These embeddings help the model understand meaning and context. Step 3 is attention. Attention layers in the model capture the strength of relationships between tokens and predict the most probable next token in a sequence. For example, after I heard a dog, the model may weight heard and dog heavily to predict bark as the next word. Language models are categorized as large language models, or LLMs, and small language models, or SLMs. LLMs are trained with vast general datasets and have billions of parameters, offering comprehensive capabilities. SLMs use focused data, have fewer parameters, and are faster and easier to fine-tune for specialized contexts. Effective prompting is key to generative AI. Start with a specific goal, provide sources to ground responses, add context, set clear expectations, and iterate based on previous results. Prompts are often augmented with system messages and conversation history to refine the model's output. Agents are generative AI applications that respond to user input or act autonomously to perform tasks. They have 3 core components: a model for reasoning and language, instructions defining goals and constraints, and tools to access knowledge or take action. Orchestration coordinates multiple AI components in a unified solution. Let's get started with generative AI in Microsoft Foundry. For further learning, you can refer to the Microsoft Learn module linked in the presentation. Microsoft Foundry is a cloud-based platform for AI development. It offers a collaborative, pro-code environment with enterprise-grade security, enabling you to explore, build, test, and deploy reliable, scalable, and secure AI solutions. Foundry projects are based on Azure resources and provide tools for managing generative AI apps and agents. The Foundry Model Catalog includes models from OpenAI, Microsoft, and others. The Agent Service Framework supports building agentic solutions, and Foundry tools enable language, vision, and information extraction capabilities. The Foundry Model Catalog offers a wide collection of generative AI models from vendors like OpenAI and Microsoft. You can select and deploy the models that best suit your needs, making them available for use in your Foundry projects. After deploying a Foundry model, you can experiment with it in the chat playground. Test questions, instructions, custom data, and parameters. Once satisfied with the results, you can deploy your customized setup as a web application. Foundry Agents lets you create AI-powered agents by specifying their name, model deployment, instructions, knowledge tools, action tools, and connected agents. You can test agents in the Agents Playground to refine their roles and capabilities. To summarize, Microsoft Foundry provides a single platform for AI development with a shared collection of resources. Foundry models allow you to choose language models for generative AI solutions, and Foundry agents offer a framework for agentic solutions. Generative AI relies on language models that represent semantic relationships between text tokens, and agents can use knowledge and tools to perform actions.